Hola nerds! Welcome to week 5, Systems of Equations. This week I think is going to be probably a little more difficult than the past 2 weeks, so I'm going to try to break down what systems of equations is little by little with each video, as you have to be able to do more and understand more of it as you go through the con activities. So for this video, I'm going to break it down to really simple things. Systems of equations are two lines working together, and there's going to be a solution for it. And that's when one line and the other line cross, that point of intersection. So let's take a look at the first type of example you're going to have to be able to solve. All right, so here's the first question. 2x plus y equals 4. We have a linear equation in standard form. Y equals 3x minus 1. We have another equation in slope-intercept form. And the question is the point 1, 2 a solution of both equations? Now, before I show you how to solve this, which is actually easier than you're thinking, let me show you what this actually looks like on a graph and explain to you what they're actually looking for. This is the graph of the two linear equations they gave us in the problem. The red line being the one that was in standard form and the blue line being the one that was in slope-intercept form. This is a system because both equations are on the same graph and there's a solution to it. That solution is the point where both intersect. And there's an ordered pair that represents that. Can you tell what the answer is to the problem right now? So here we are. This is what it looks like on com. There's no graph, so we're gonna have to figure out how to solve it. The question was, is the point, the ordered pair, 1, 2, a solution of both equations? As we saw on the graph I just showed you, that was the point of intersection, which means yes, it is. But since you're not given a graph, we have to figure out how to do it algebraically. So let me show you. So algebraically is a little bit different than on the graph. On the graph, it was real easy to see where the two lines intersected and find the ordered pair. Instead, when you do it algebraically, we're given the ordered pair and you need to plug it in to see if it's true. So you have to do it to both equations. It has to be true for this one and this one when you plug it in. And that's when you can say it's a solution. So what do we need to do? We have an x and a y coordinate. We're going to plug it into our x and our y values. We're going to solve, and if this side equals this side at the end, if it's a true statement, that means it works for this equation. Then we're going to do the same thing here. We're going to take our 1, plug it in for x, our 2, plug it in for y. We're going to solve, and if this side equals this side for this equation as well, then and it's true. If both are true, that means it is the solution. All right, so let's see if 1, 2, which we know works because we saw that that was the intersection. And I don't know why every time I say intersection, I do this, but let's do it. So x value is 1, so now let's replace it as 2 times 1 plus our y, which is 2, equals 4. What's 2 times 1? 2. 2 plus 2 equal 4. 2 plus 2 is 4. Does 4 equal 4? Yes. So we know that it's true for this side. Now we need to do the same thing and plug in our coordinates in here and see if it equals each other. And then that way we'll know if it's a solution or not. So y, which we know is 2, equals 3 times our x value minus 1. All right. 2 equals, what's 3 times 1? 3. Minus 1, and then 2 equals, what's 3 minus 1? 2. 2 equals 2. So 4 equals 4 on this side, so it's a solution to this equation. 2 equals 2 on this side, so it's a solution to this equation. Therefore, it's a solution to our systems of equation. Bam. Love you, miss you.